A Solar-Powered Economy. I am Ann Fisher, Senior Editor of PV Magazine USA, and I'm joined here by my colleague, Editor Ryan Kennedy. We're moderating this live virtual event, which we will bring together an impressive lineup of experts in the solar industry to discuss the most pressing issues in solar and storage in the U.S. Today is day 3 of this 3-day event, and today's theme is Solar Ignites U.S. Manufacturing. The onshoring of the solar supply chain has begun, contributing to high-paying jobs, not just in solar manufacturing, but in the many supporting industries. The U.S. solar industry is now a model of how policy and incentives can drive both a new and growing economy.
In just a few minutes, we'll hear from our keynote speaker, John Smirnow of Smirnow Law. He has nearly 3 decades of international trade experience, and many of you know him as the Senior Vice President of Supply Chain and Sustainability and General Counsel at the Solar Energy Industries Association. After the keynote, we'll hear from Brett Henderson, co-founder and CEO of SolarPanelRecycling.com. Then we'll take a quick break and come back for a presentation by Scott Wharton from the startup Tandem PV, a company that is pairing conventional silicon solar with perovskite materials for panels that may have the potential for up to 40% more powerful than those used today. And then following that, we'll have our main panel discussion. This will include panelists from Clean Energy Associates, Standard Solar, Solar Energy Manufacturers for America, and Soltec. We'll take a deep dive into what the domestic manufacturing landscape looks like and what the future will hold. Topics will include manufacturing capacities across the supply chain, the implementation of tax credits, transferabilities, tariffs, and more. And before we hear from John Smirnow, I'd like to thank our platinum partners, Longy, Trina Solar, and our gold partners, Aurora, Soltec, and Stobly. Thanks for joining us today. And you can check the agenda in the handout sections and send your questions to the question and answer session in the chat feature. Each day of the event, including today, the final day, will also do a drawing to receive a 1-year digital subscription to PV Magazine. So be sure to stick around to check out that prize drawing.
Now it's my pleasure to introduce today's keynote speaker, John Smirnow. With nearly 3 decades of international trade experience and former associate and counsel to 2 international law firms, you may know him from his time as Senior Vice President for Supply Chain and Sustainability and General Counsel of the Solar Energy Industries Association, or SEA. At SEA, he led international trade advocacy and helped save the U.S. solar industry billions of dollars in avoided duty costs. Smirnow also positioned SEA as the leading proponent of domestic solar manufacturing and was closely involved in the development of the Inflation Reduction Act's domestic manufacturing provisions. Welcome, John.
Thank you, Ann. Great. Well, thanks again, Ann and Ryan, Diane, everybody else at PV Magazine USA, and thank you for attending this session. I'm going to provide an overview of my personal views on what I think is necessary to expand U.S. solar manufacturing leadership. And the title is particularly important because I think we already have quite a bit of solar manufacturing leadership, and I want to speak to that. These views are my personal views, not the views of any of my clients at Smirnow Law. First thing I want to cover today, and I'm going to go through really 5 key points. One is that solar energy is now a national security imperative, and I think this is something the industry has to recognize in a very public way, and certainly internally. I also want to talk about the importance of a robust industrial policy to the success of the U.S. solar manufacturing industry, and certainly that is being led by the Inflation Reduction Act. I'm then going to talk about the importance of growing our solar manufacturing relationships with friends and allies. And in particular, there I'm going to talk about the European community, European Union, as well as India. Then I'm going to talk, perhaps uncomfortably in some aspects, about the U.S.-China relationship and the need to restore balance to that relationship. All you have to do is look at the capacity numbers across every segment of the solar industry, and you'll see that there is no balance there anymore. There used to be, and I think that's an important area where we can make significant progress. And then what I'm calling for today is that the industry adopt a target of 100 gigawatts of solar manufacturing capacity by 2030. The industry already has a target of 100 gigawatts of renewable energy capacity by 2030, but I believe that the way the global industry is developing, that we should be more aggressive as an industry in our target. So today I'm calling on the industry to set a target of 100 gigawatts of solar manufacturing, just solar alone, by 2030. And I think that is very achievable. So getting into my presentation, solar energy and national security. As an industry, we've done an amazing job over the last decade and a half of driving down the cost of solar energy. And admittedly, a lot of the massive government subsidy support that the China has put into this industry has been critical to driving down the cost of solar energy, where today we're now the largest source of new electricity generation capacity in the United States. To me, that alone speaks to solar now becoming a critical aspect of America's energy infrastructure. And certainly the energy infrastructure of the United States is essential to our country's national security. In this context, it's not in the context of national security, it's not enough just to say we need to deploy more solar, build more power stations. That's fine, but in doing that, if we're over-reliant on imports or over-reliant on a country or a few countries, that is not a resilient energy infrastructure system. And that's why I think building a robust 100 gigawatt solar manufacturing base here in the United States is absolutely critical. But to do this, to build this the right way, we really need to get away from this driving narrative of, it's all about cost reduction. And even today, I still hear people say, well, Europe, they're able to buy solar panels for 10 cents a watt or 9 cents a watt. Why can't we do that in the U.S.? I also hear, if China wants to subsidize solar energy, well, we should build warehouses and just buy all that and take advantage of all those Chinese government subsidies. You also hear the third narrative, though less so now, is that, look at Apple, one of the most valuable companies in the world, and they don't make anything in the U.S. It's all U.S.-based engineering, design. I think each of those arguments are invalid. And, particularly on the first point about the 10 cents a watt, well, that's an artificial price. All you have to do is look at what's coming out of China, the China PV Industry Association, the Chinese government, the calls for a more reasonable capacity there. Even a solar leader there had said that the Chinese industry is undergoing an ice age. Well, whose fault is that? It's not our fault. We don't want to be a part of that ice age. We don't want that ice age to freeze the growth of what we're seeing in the U.S. right now. With this very exciting new development in solar energy manufacturing capacity. In addition, what's really important is that all segments of our industry need to be healthy. If the developers are making 20% margins and the manufacturers are barely able to survive, even with the Inflation Reduction Act, well, that's a system that's out of balance, and we need to do something about that. Now, the next point I want to talk about, and it's really exciting as to what we're seeing with the Inflation Reduction Act. a robust industrial policy. One thing I want to recognize here is that industrial policy is strategic state and federal investments designed to grow America's economy, strengthen national security, and reduce carbon emissions. All three of those are equally important. Carbon emissions, reducing carbon emissions has been maybe the principal driver so far, absolutely going to continue to be an important driver, but we need to start thinking a little bit more about solar manufacturing as critical to growing the economy and strengthening our national security. Technology leadership today, this constant narrative of, we've lost the battle. There was a Bloomberg article, felt more like a hit piece to me than anything a few weeks ago that it basically said we've lost. The U.S. lost the solar industry. Let's just give up and walk away. Well, that's not what I'm doing, and I hope that's not what you're doing either. That's not what First Solar is doing. That's not what Q-Cells is doing. That's not what LONGi, JA, Trina, that's not what they're doing. They're investing in American manufacturing because they believe we can and should build a manufacturing base. And we do have technology leadership here today. Look at First Solar, thin film. No one even comes close to being a leader like them on thin film. Polysilicon manufacturing capacity. Okay, we have a relatively small amount of polysilicon manufacturing capacity relative to China, but we still have $10 billion of manufacturing, polysilicon manufacturing assets here today. In addition, the US and Japan, Germany produce semi-grade polysilicon. A lot of the factories coming out of China, I'm actually not sure if anyone yet has qualified to be able to supply semiconductor grade polysilicon. So we have existing technology leadership today. Let's talk about trackers. A lot of technology in trackers, basic mechanical systems, but the US is a leader in tracker technology, critical to big utility scale systems. Microinverters. We have one of the leading leading microinverter manufacturer, US company, which has brought all of their manufacturing capacity here back to the US. Lots of US IP technology there. I also want to talk about the importance of manufacturing as anchoring the community. Sure, big utility scale projects drive many jobs. You could have 1,000 people on a job site for several months. But at the end of the day, those workers are going to move on to another site. They don't anchor a community. A manufacturing facility actually anchors a community. People can have careers in the same community. Manufacturing leads to more shipping. All of the suppliers of the manufacturing, the restaurant across the street, the printing, copying company down the way. All of this comes from manufacturing, which has the highest jobs multiplier of any industry. Some have even said that manufacturing numbers of one manufacturing job creates as many as 7 downstream jobs. Now, here, people, I want to dispel a few additional myths. I think I've already talked about the services one that, you don't want to just be buying imports. You want to actually make manufacturing capacity here. And one of the myths we see is the automation. Well, these manufacturing facilities, they're all automated. There aren't going to be many workers. Well, that's great. We want to, automation is good. We want to increase the output by each worker. But let's look beyond the manufacturing facility. And once we have manufacturing capacity, why wouldn't we then want to be building the automation equipment? There's a whole nother line of business opportunities there that if you just focus on that single factory in automation and say, oh, only a few jobs, let's not focus on that. You're missing a much bigger opportunity. There's also a lot of important technology development that happens on the factory floor. I'll use one example of ingot manufacturing. So over time, ingot manufacturing, you would fill the crucible, a single crucible, you pull a crystal out of there. Well, now you have direct feed, and so you're creating ingots while the raw materials are going in, significantly increasing the efficiency of that. that's something that would be hard to do to me unless you actually are operating ingot pullers. You can see it, and the engineers working on the factory floor can then develop that technology. And so by bringing this technology here, we're creating a better opportunity to improve that technology in the United States. So the next piece I want to talk about, friends and allies. Here, I don't think we're doing enough to, diversifying the supply chain of working with our friends and allies. And I see a couple really key opportunities for the industry to work on. One, in the United States, we don't make a lot of the manufacturing equipment, whether it's the equipment that makes the panels, whether it's the ingot pullers, the wire saw equipment. Not a lot of that's made in the U.S. Most of that today is made in China. Well, even the International Energy Agency has said that what's critical to the long-term health of the global renewable energy is diversification, resiliency, not relying on just one country or regions. And the European, 10 years ago, Europe were the leaders in making manufacturing equipment, cell equipment, the equipment that, the laminators that make the solar panels. And there's still a lot of expertise there. It's atrophied for sure, but I think there's still a big opportunity for the US to work with European equipment manufacturers and develop that cell technology, for example. It would be great if Europe focuses on right now making the equipment, the machine tools that we can then bring into the United States. I see an important opportunity. I would say that SIA and VDMO had a lot of panels at the recent RE Plus where they're working on this. I think it's a good start, but I think a lot more government industry work needs to go into that. I also see India as a great opportunity for more collaboration. In some ways, India has always been a little, at least the last couple of years, has been one step ahead of the United States in creating a solar manufacturing base. The PLI incentive, for example, production linked incentive, where you build a panel in India and you get a certain credit for that, is very similar, if almost identical, to the IRA's 45X. And so India really understands the need, like we do now, to want to have a solar manufacturing base, diverse across the entire supply chain. And friends and allies, I define that as people who share our values as a country. And I see that the Europeans in India, that we really do, in many ways share the same values. And so, Indian solar cells, lots of new cell capacity coming online. I think as we grow our cell production in the U.S., that could be an opportunity there. Raw materials, some of the glass, for example, or some of the framing. As we grow our capacity here in the U.S., I can see opportunities there. The one thing I would caution, though, is that we don't want our friends and allies to be a conduit for products that we wouldn't want coming directly from China or another region because they're problematic. For example, what we've seen in the U.S. is under the Uyghur Forced Labor Prevention Act, we saw a product that was shifting first from Southeast Asia. Customs put a lot of focus on that product. And then, we saw supply slow down from there. And we wouldn't want India to then be a conduit for products that contain problematic inputs, like untraceable or difficult to trace polysilicon. Really my only word of caution. The other thing, too, is I served on a Department of Commerce Renewable Energy Advisory Committee, and the government was very committed to growing manufacturing exports. It was mainly an export focus. And our message was always, well, first you have to be able to sell it in the US market to be competitive before you could export. We're now getting to the point where we're starting to build it making this equipment in the U.S. And now really is the opportunity to start, in the context of friends and allies, to start looking for export opportunities, particularly through poverty or energy poverty, alleviating energy poverty. There are few technologies better suited to that than solar energy. So I see some longer term opportunities there, but I think now's the time to start working on that. So this, perhaps is maybe some of the more challenging aspects of my presentation today, more sensitive, and it's really about the heart of a lot of this is about U.S.-China competition. I have spent a lot of time in China. I gave presentations at all the big events at SNEC, some of the internal events. Have good relationships with China leadership, but it's been a couple years since I've been there, and the main reason for that is I also led the industry's advocacy on moving the supply chain out of Xinjiang and addressing human rights. And because of that work, I'm not sure I'd be that comfortable going to China right now. And that's unfortunate, because I think an important part of mutual respect and win-win competition, win-win, mutual respect, collaboration. These were all phrases that are very important, critical to Chinese culture. Absolutely respect that, believe that. But mutual respect really goes both ways, and an important element of mutual respect is that you respect each other's views. And sometimes I think with forced labor that's not so clear. I use what's happening with the bifurcation. So UFLPA, there's a stream non-Xinjiang that comes to the U.S. eventually, but there's a whole stream of supply chain that is sourcing products from Xinjiang and going to the rest of the world. I think that bifurcation is going to be increasingly problematic from the U.S. I also think as we look to investments into the U.S. that we need to have reasonable guardrails for companies that are effectively under the direction and control of the Chinese government. And I think that's something that we're going to see here in the next Congress. So, let's get back to a balanced U.S.-China relationship. Let's respect each other's differences. And I think there could be continued perhaps new opportunities there. So just wrapping up my presentation, again, putting out for the industry to consider 100 gigawatts of solar manufacturing capacity by 2030. Let's start talking about American solar energy independence. Again, you've heard me say all key segments of the market need to be healthy. We can't live in a world where it's all about 10-cent modules and the manufacturing base has no opportunity to make a profit. We need to have a pricing environment in the U.S. where the pricing is sustainable. You can get a fair price. You're not making monopolistic profits, but a fair price to invest in R&D and grow. And to get there, I think we really need to start recognizing that the narrative of solar as a sole objective isn't going to serve our industry in the long run. And then finally, a lot of the benefit of all this is that we're going to see, with more U.S. manufacturing, a cleaner U.S. supply chain. So thanks for your time, and Anne and Ryan, I would be happy to answer any questions.
Yes, thank you, John. We appreciate the ambitious goal of raising the bar for solar manufacturing. And there's clearly great opportunity to onshore the entire supply chain. We do have a few questions here for you, so let's get to those.
Yeah, we have one question from the audience here. They said, what do you mean when you say the industry needs to recognize that solar energy is a national security imperative? It seems that you mean that U.S. solar product buyers must be willing to pay a premium for U.S. made solar products.
I agree with that. Yeah, I agree that people need to recognize that solar as a national security imperative, that means you need to make the product in the United States, which necessarily means in this environment of massive global overcapacity, that you're going to have to pay more in the US. But you shouldn't look at it as just, oh, we got to pay more in the US, but geez, I should be getting it for 10 cents because that's what they're getting it for in Europe. That's artificial. It's artificial pricing. We need to shift the narrative to, we want to make it in the US because it's critical to our national security. We're going to have to pay more for that. That price should be sustainable pricing, not the artificial pricing that we see globally.
Thanks. And a follow on to that question was they said that traceability seems to be one lever, one motivation. Are there any other levers that the U.S. can push on to encourage more purchasing from domestic manufacturers?
I think there are a whole host of ideas that SEA and ACP in particular have talked about. I think the industry needs to, in this context, come together to think more about how do we create a more sustainable pricing environment in the US. I don't think there's any one solution. It's under this rubric, this umbrella of an industrial policy. A critical element of industrial policy is federal investments. And we're seeing that through the Inflation Reduction Act. But I think there are other tools, a whole host of ideas that I think are out there, but I wouldn't identify any one single issue. One important point that I wanted to mention that I forgot about on the federal investment side is that not only is the federal government investing in solar energy, but the state governments are investing in solar energy. So you think of all of these new manufacturing facilities, it's Texas, Georgia, the citizens of those states are providing tax credits or rebates or government funding to help recruit those facilities there. And I think that's something that's overlooked. It's one of the reasons why I think even if we were to see a second Trump administration, that the solar manufacturing base, these investments are on pretty solid ground because the state, the citizens of those states are, whether they realize it or not, have invested in those facilities as well.
Yeah, you sort of touched on the next question I had, which was, are you seeing any political threats to 45X or any other key U.S. manufacturing related federal policies?
Yeah, I mean, certainly the election, the outcome of the election is going to have a massive impact on our industry. I think the biggest thing is going to be the uncertainty of it. If we see another Trump administration, we just really no one really knows what a second Trump administration is going to look like for the country as a whole, not to mention the solar industry. And so it's just that massive uncertainty. If you try to prognosticate and get a lot of questions of what do all these credits look like with the Trump administration? The thing that I point to is that I believe that a Trump administration would be very supportive of solar manufacturing. Now, are they going to be supportive of Chinese companies investing in U.S. solar manufacturing? No. What are going to be the implications of that? Are they going to be supportive of 45X, domestic content? I think they would be more likely to be supportive of that than maybe some of the rhetoric that we're hearing on the campaign trail from the Trump side. But if we see President Harris, I think we're going to see status quo effectively, very similar policies, and we'll all be quite positive for the solar industry because I think there's going to be a lot less uncertainty.
Okay, I have one from the audience. 2030 seems to be the year predicted that will turn the tide for renewable energy, and that's just 5 years away. With the huge increase in electrical demand predicted, let me summarize this. Would you agree that the problem, that energy really isn't the problem, it's more what the energy is being used for that's the problem?
Yeah, so I guess I wouldn't phrase it as problems. The first thing I would say is 2030. It's 2030 is linked to targets, environmental targets. We also have the Biden administration 2035. So I think a lot of the goals that are there are linked to those. Also, too, it's 2030. It's a big number. It's it's something that catches your attention. And when you set a target, you want to have, I don't know, you want to have some PR behind it, right? And I think the 2030 target is in that context. But I also think it's setting a 100 gigawatt solar energy goal by 2030 is achievable. I mean, we see as estimated that we're going to do, we'll have roughly 40 gigawatts of polysilicon production capacity here in a couple of years. 6 years, we could just 2x that, which would mean about 200,000 metric tons of polysilicon capacity in the U.S. I mean, there's a plant going up in Oman that's a single facility that's 100,000. And so, as I thought about the goal for solar of 50 gigawatts across the supply chain, while China's doing 100 in this country, 100 in that country, it just seemed to me that really seemed to be a small number. And then the question about energy, and I'm starting to believe increasingly that as we digitize literally everything, we're going to way overshoot forecasts of energy. My son is an electrician, and he recently was working on building a server farm out in Virginia, and they have the diesel gen sets there that are supporting that for resiliency. But those diesel gen sets are not now principally used for resiliency. They're principally used for electricity generation, and they're running today every day for 20% of the time to provide electricity for that facility. So solar is going to play a critically important role, as is wind and hydro, modular nuclear. This all above is critical. We have to have this all above energy strategy while we continue to clean the energy. So as energy grows, we want to get better and better at all the new generating capacity coming online, being clean, renewable. But it's going to be a while that we really get there. But we got to stick with it.
Okay,
Thanks.
thank
And
you.
it looks like we have time for maybe one more question. Circling back to that 100 gigawatts by 2030 target, is that for across the entire supply chain, all the way through polysilicon? And also, does that also include balance of systems like racking, inverters? And then finally, which do you think is the most difficult leg of the supply chain to hit that 100 gigawatt target?
Yeah, so I think that my view, that's across the supply chain. So 100 gigawatts of poly, ingot, cell, module, trackers. I think trackers, we're going to be there, no problem. Inverters, I include module level power electronics, microinverters, optimizers, transformers. So the balance of some of the key elements. Like, should we have a list of every single thing that goes into a solar power station, be 100 gigawatts supply? That no, but I think there are the main key elements that are necessary for a functioning system that would be hard to get if you weren't producing those, and there was some global issue. And what was the second part of your question?
That was which would be the most difficult leg of the supply chain?
Yeah. I think, inverters, one thing about, I don't think inverters is going to be difficult. We're starting to see populated printed circuit board assemblies populated in the US. So that is starting to move over. We're seeing from a tracker, motor manufacturing moving. Maybe I would say probably the hardest is ingot pulling, because it's a lot of CapEx. Most of the technology, overwhelmingly, most of the technology is in China, and that is pretty squarely in a very sensitive area of China. not wanting to let go of that technology in the context of the U.S. bipartisan government support of not wanting Chinese investments. So I think because all of that technology mainly is in China, that seems to me to be the hardest piece to really get that at scale in the United States. Polysilicon capacity, I think the challenge there is we just need to get purchasers to recognize that to have a sustainable polysilicon industry, people need to be paying sustainable prices. That $5 a kilogram polysilicon is, any industry is not going to survive on that for long term.
Thank you. Well, looks like that's all we have for time now. Really appreciate your time, John,
Thank
and
you.
really excited to see what the next 5 to 10 years looks like here as we see the Inflation Reduction Act go to work.
Yeah, I'm very, very optimistic about where we are today and where we're going to be in 5 years, and really, really appreciate this opportunity. Thanks, everyone.
Thank you. So we've now heard about the need for manufacturing across the entire supply chain. And now we'll hear about the end of the life for solar modules. We have with us today Brett Henderson, Chief Executive Officer of solarpanelrecycling.com. He'll dispel some of the myths around what happens to used solar panels, exactly what's being recycled, and how the extracted materials are going to serve manufacturers. Brett Henderson is the co-founder and CEO of solarpanelrecycling.com. With a lifelong commitment to recycling, Brett has over 15 years of experience in the recycling industry. As vice president of Powerhouse Recycling, Brett has advocated for a circular economy, all while creating eco-friendly and efficient recycling programs for Fortune 100 companies, government agencies, universities, manufacturers, and more. Thanks for joining us today, Brett.
Thank you, Ryan and Ann. How are you?
Doing well.
I want to thank Ann and Ryan again and PV Magazine USA for giving us the opportunity to discuss end-of-life solar in the US and how that market stands. And hopefully throughout the presentation, I could piggyback off of John a little bit about supply chain and how proper recycling, true recycling of solar panels can play an important role in that. So we'll discuss a little bit today about the demand and the volume in end-of-life solar panels, the technology that is rapidly evolving, and again, how we could kind of support the supply chain, not just in the solar industry, but in a myriad of supply chain applications in the US with the goal of getting that into solar. Let's set the stage first. So discussing the volume of end-of-life of modules and panels here, the EPA, utilizing the research of RENA, says by 2030, so we're only looking about 5.5 years out here, over 1 million tons of PV modules will start hitting end-of-life waste stream, and by 2050, 10 million tons. To put that in perspective a little bit, you can max out a truck with DOT regulations and weight with about 20 tons. So you're talking, that amount of semi-trucks that need to transport what is now an end-of-life module to a closest recycling facility. What we actually anticipate here at SPR with ongoing conversations with energy utilities, project managers, project planners, EPCs, we actually anticipate that volume is going to be even higher. We're pretty bullish on that. If you look at the graph kind of on your screen here, you look at SEIA's installation numbers. And as we all know, in the last 3, 4, or 5 years, we've just really seen this spike in installations and panels going in throughout the country. Another anticipation we have here at SPR is a faster timeline for them hitting end of life. So we'll dive into that a little bit here. Expected panel life from manufacturers is typically coming out between 25 and 30 years for an expectation. What we have seen for panels hitting our recycling facilities throughout the US is some repower and tech upgrades, if you will, happening closer to that 10 to 15 year mark. Obviously, if you could produce more energy and you have 200-watt panels in and you have the ability to go get 400, 600, 800-watt panels, it's providing this refresh, if you will, similar to the iPhone, right? My son has the iPhone 14 and is already begging for the 16 here. So you kind of see these technology upgrades really driving the time that these panels may or may not be in service. And then you obviously have weather events and regular O&M breakage. A weather event, as we all know, could happen at any time. We've had some here recently that have affected, where we're headquartered here in North Carolina, and Hurricane Helene, as well as some events, Milton down in Florida. So a weather event could obviously drastically take that panel that has that 25 to 30 year service life and move it to end of life stream much quicker. And then what we're seeing quite a bit of is obviously the transportation and construction breakage. So, panels are glass, right? So they're a little bit challenging to transport with 100% rate of them not breaking to get to the construction site. So we see quite a bit of panels that break during installation or even the transportation to the solar facility, ultimately bringing the life of that panel to zero here. So with all of that, if you look at the panels that are throughput in our North Carolina, Georgia, and Texas facilities, we're having an average panel life of about 11 years. Discussing a little bit about the source of those panels and what we think our forecast will be, again, discussing with major utilities, energies, and project planning that we're involved in. And this year, if you see that blue part of that kind of pie chart there, most of the panels that are hitting our recycling facilities are from construction breakage or transportation and installation breakage, with weather events falling right behind that. But what we see is that shift towards 2029, only 5 years out, we think the bulk of that will be from decoms and repowers. We're part of some project planning in 2025 that is facilities that will have 150,000 panels, 200,000 panels, 300,000 panels that are getting ready to be repowered here. So we really will see the bulk of that source of those panels hitting our stream, kind of shifting towards panels that are coming out for tech upgrades or repowers. And why that's important is when we started doing our R&D to develop these dedicated recycling lines to capture clean commodities, to enter back into the supply chain, which I'll discuss a little bit later in the presentation. A lot of that was based around the fact that these are single-sided glass panels, mostly silicon panels in the US market. So a lot of our recycling lines were dedicated towards that. But what was happening is, as we were getting a lot of this newer tech hitting our recycling streams, again, due to maybe a weather event of a newer tech panel that just went online, or due to the breakage during construction or transportation, we were getting a lot of bifacial double-sided glass panels hitting our lines. So we've had to start to rapidly evolve already the technology to capture these clean commodities. Now we'll hop a little bit into the demand in recycling in the United States, and we'll talk about some of those driving forces. We'll get right into it and dive into the negative driving force. So currently the cost of solar panels to go through a true recycling process, which we'll define here in just a little bit, those are higher than landfills or incomplete recycling. So we're seeing most of the panels in the United States still, unfortunately, finding their ways to our local landfills or to an incomplete recycler. Incomplete recycling is when it may go to a scrap metal yard or recycler that's ultimately going to capture the aluminum frame, which is just 4 to 6% of the panel composition, and then the other 94% ultimately finds its way to the landfill. So by not capturing the glass and the clean silicon and the other metals, we're not going to be able to support the supply chain. So what we see here is current end-of-life solar panel costs that include transportation. So your landfill disposal costs are typically around $2 to $5 a panel. That's including transportation. Obviously, landfills are more local, so your transportation runs a little bit shorter. Incomplete recycling, we've seen people taking panels for free, again, because they're going to grab that couple dollars of aluminum value, and then the other negative value commodities and the cost to actually cleanly separate them, just doesn't occur. It ends up in the landfill. And currently true recycling has a big gap, and the onus is on us and other true recyclers to continue to advance their technology to bring those costs lower to the landfill. But that's roughly about $14 to $20 a panel. That large range, again, is due to transportation costs, as well as is it double-sided glass, single-sided glass, and some other technologies out there as well may affect that. But on the cost side, we could also consider this a positive driving force. Some of the national utilities and energy companies we've been partnered with, the last couple of years here, we've actually, through a myriad of reasons that we'll discuss in a second, have been able to bring our recycling costs down about 42% in the last 36 months. That's mostly driven by technology advances. If you tour one of our plants today, and then in 6 months, and then in another year, you're going to see rapid evolving technology with the goal to get cleaner and more pure commodities that we could then put into various supply chains. Obviously, in any industry, the more volume you get, you start realizing some economies of scale, and our volume's increasing year over year pretty substantially here. We have new supply chain markets that are more or less getting interested in taking our clean commodities and introducing them into their manufacturing. And then we are continuously putting up other regional facilities to really close that transportation cost side of this, where you could bring the panel transportation down to maybe $1 a panel. Again, only about 500 could fit on a semi truck with weight restrictions. Some other driving forces that are positive towards true recycling demand for end-of-life panels is end-of-life policy and association leadership such as SEA here. So this map, as you see here, it's 31 states, believe it or not, have some level of decommissioning or recycling policy. The important note with that, though, is that they are rapidly evolving and ever changing. And believe it or not, it's mostly bipartisan support at the state level. It might be for wildly different reasons, but they are bipartisan support of end-of-life panels diverting from landfills and incomplete recycling. And the main reason for that is landfill capacity. For example, in North Carolina, the landfills that service the most populated areas have less than a 10-year life left with them. So this is a new waste stream that is, just coming down the pipeline to hit us with an avalanche of volume. So by diverting these from the landfill and getting them back into supply chain, it creates jobs, it keeps landfill costs lower, which then will keep encouraging growth in the state. The EPA currently has a classification that solar panels are hazardous unless you get a T-clip or some sort of testing to show that they are not. They have released last year in 2023 that they're going to adjust that classification to universal waste to more or less encourage more recycling. That isn't in effect yet, but that is coming down the pipeline. And then obviously we have SEA, the largest industry association here, that has had a national PV recycling program in place, and they're even taking that a step further in terms of making a certification for recyclers for best practices, assuring that they're getting recovery rates and clean commodity separations. All of these are helping drive panels and their demand back into the recycling stream. And then finally, some positive driving forces are actually coming a little bit out of the negative side of misconceptions and community engagement. So one misconception that we hear a lot is that we don't have to worry about this for 25 to 30 years. And obviously the stats that we have shown and the panels that are already hitting true recycling streams is significant, and that's set here to grow tremendously in the next 3, 4, 5 years. But what we commonly hear from clean energy opponents is just categorically false. You see these on LinkedIn posts or news articles after a storm hits or a solar facility had some level of a failure. And here's just a handful of ones that we see all the time. And solar cannot be recycled end of life. And we obviously know that's not true. End of life panels are contaminated in our water and air, and it's not clean energy if they buried in the landfill. So we have seen this new wave of stakeholders or asset owners recognizing that there is end-of-life management for these and the importance of not just diverting them to a landfill or an incomplete recycler. And, what goes hand in hand in the clean energy space is environmental stewardship. So ESG reporting in the United States is becoming more and more prevalent and at the forefront. And that mission to keep clean energy just that, clean through end of life, is becoming more and more, under the microscope at some asset owners that, are really just trying to keep up with the demand of construction. Let's talk about end of life. Education and outreach is extremely important. That onus is on us as a recycler and other recyclers throughout the country to let the industry know how it's getting done, have transparency, integrity in the industry, and to really understand cost and what the future of those costs would be. And then options, and again, as options to recycle become more and more well-known in the industry, we're starting to see more of that hit the recycling stream. So we'll hop into the technology here. And first, I promise we'll define true solar panel recycling. So true solar panel recycling is going to be the clean separation and recovery of all materials within a PV module, including aluminum, glass, silicon, metals, and plastics, to be reintroduced into the supply chain. Here's an example. This is from LightSource VP of the composition of the panel. It's about 76 to 89% glass, depending on the make model. Plastic could be 4 to 10% of that, aluminum 6 to 8%, then you have your silicon and other metals like silver, lead, and copper. And it's important that the technology and the recyclers are cleanly separating these so they can be reintroduced into supply chains. When we commingle these items, it does not allow them to be reused into very many applications at all. So the current technology globally and in the US, there's a handful of options. It's mechanical, thermal, or metallurgical, and chemical, if you will. At SPR, we mostly use mechanical. We do this because it has a very low energy consumption, and we're also able to be nimble as new types of technologies and new types of panels hit, so we can continuously update our technologies. The higher the purity that we're recovering of these commodities, we're not commingling. The glass needs to stay pure, obviously, if that's going to be 78 to 80% of this. The more higher the purity, the more applications these get in the supply chains. And again, rapid advances are really important. You have to have ongoing R&D and stay up to date with different panels coming through the line. We utilize different technologies such as AI to talk to different parts of the machines and the separation. It's automated. We have been working in the background for 6-7 months for a bifacial solution that gives us the purities and separation recovery that we want, which is 98% plus, and other types of cyclones and air density. And finally, let's talk about, bring this all back to today's topic, the supply chain and opportunities in solar. So currently there's applications in various supply chains to take the clean glass collet, to take the silicon, to take the aluminum metals, and get these reintroduced back into manufacturing. Again, with the importance of it going to a true recycler that can capture and separate these clean commodities. But where the major opportunities here is we see more onshoring of solar manufacturing is getting some of this back into the solar industry as well. It shouldn't be an all or nothing, a goal here. As more and more of these panels hit end of life, it's extremely important to make sure that the commodities generated are scalable and have a supply chain home. But what we'll see as more components for the US solar manufacturing comes onshore, such as the glass and maybe the silicon wafers themselves, is an important role that true recyclers such as SPR could play in feeding those supply chains and helping to really support the US PV supply chain and manufacturing scalability. And again, that glass collet needs to stay clean for that to occur. We're very optimistic that within a few years, recycled glass collet can go back into new solar glass manufacturing. We're optimistic with partnerships with decades and decades long established glass manufacturers in the US that plan to bring online high quality solar glass lines that could use this recycled glass, call it. We think this is not too far down the road for that to occur. And finally, to close up here, a few points I'd love to leave the audience with is we simply cannot, as an industry, choose to landfill solar equipment, all the while pushing for clean energy support. We also have this rare and wonderful and exciting opportunity to establish a robust recycling industry proactively in the United States, which is rare for a new waste stream ahead of this avalanche of volume. If all stakeholders buy into diverting their end-of-life panels to true recyclers versus landfills and incomplete recycling, we could start capturing these clean commodities, and the solar panel recycling industry can support the US PV recycling supply chain. And I'll flip it back over to you, Ann and Ryan.
Okay, I think we have, we're almost out of time, but let's take a couple minutes just to ask a couple of questions. There's one question here from the audience on repurposing solar panels that still work, but may have been replaced with newer technology. So is SPR involved with that market?
We are. So at SPR, we are involved in the reuse and refurbishment side of it. It's a low percentage that's hitting the recycling stream at the moment, though. Going back early on, you see the percentages are coming from breakage and construction and transportation breakage. It's also to be determined as well, once a lot of repowers do occur and you start having hundreds of thousands and millions and tens of millions of panels hitting the secondary market stream, is there enough demand for that globally? You unfortunately don't get to just send a panel out that's still working and it just plugs into, or the same inverter or attaches to the same infrastructure that you'll need in terms of racking. So there is these small, boutique markets that could accept them, but we're to be determined on how much demand will be there when the supply really starts growing.
Okay.
Thank you. And you mentioned that there's a possibility that the EPA will lower the status of solar panels from a hazardous material to like a standard recycling material. How would this help support more recycling? What would it change?
Yeah, a lot of this is on the transportation sides and where how and where panels can go to. So currently it has this hazardous waste designation, which ultimately means that you have to have some sort of T-clip showing that it's not meeting hazardous waste criteria for it to be able to freely transport to a recycling facility. We at SPR have something called a transfer-based exclusion, where we've been able to show we have viable markets, clean commodity separation. So a lot of our clientele does not need to necessarily go get this T-clip testing, but it does deter and make a little bit more of red tape and challenges to move panels. The EPA has already came out in 2023 and said they're going to turn it to universal waste, which makes it a little bit easier to handle, to transport, and to report on. But it's also important to note that these classifications are done at the state level. It's just as states are starting to get these policies in place, it kind of falls back on what the EPA designation is until a state one has that set up and in place.
Thank you. Well, that's about all we have for time. Really appreciate your insights, and it's good to put it in context. I think we often think about the sun being this unlimited resource for us, but we have to think about the other physical resource side here on Earth and how we're using it. So really appreciate your time. And we'll now take a 5-minute break. And when we come back, we'll be joined by Scott Wharton, CEO of Tandem PV. Thanks again, Brett.
Welcome back. We have with us Scott Wharton, CEO of Tandem PV, who prior to joining Tandem PV was Vice President and General Manager of the B2B group at Logitech. Before that, he drove growth in Logitech's video collaboration division, building it from a small player in 2015 to the global market leader for video equipment, growing it from 62 million to over 1 billion annually. Now Scott heads up Tandem PV, a company founded in Silicon Valley in 2016 that's developing state-of-the-art perovskite-based solar panels suited for broad-scale deployment. Welcome, Scott.
Thanks for PV Magazine for hosting this talk.
Glad to have you.
Great. How do we go to the next slide?
You can move them.
Okay. Oh, there we go. All right, great. Well, good morning, everybody. I'm going to talk about where solar is going from a startup perspective for about 10 minutes. So I'm going to start with this slide that shows the growth of solar and where it is in respect to other energy sources. And while we're talking about a lot of the growth of solar and success, I think one of the things that's interesting about this slide is that solar is actually the lowest source of energy in the United States today. But in the next 10 years, it's going to catapult up to the top with the combination of solar and wind. I think the other thing that's interesting about it is that it's primarily going to be at the expense of coal based on this slide, and most of the other sources, gas, hydro, and nuclear, will roughly stay flat to growing a little bit. Why is this happening? Well, part of it is just the unbelievable and dramatic reduction in cost in both solar and battery technology. So solar, as many people here know, has dropped about 90%, maybe more in the last 10 years. So it's really gone from being a niche technology to the lowest cost application, which is driving a lot of this growth. And then I think there's a whole bunch of discussion about, all right, solar, the joke is it only shines during the day, which we know is true. But there's increasingly a reduction in cost of batteries that allow solar to be not only a peak technology, but also a baseline technology. And today, if you look at where solar is successful, it's true that it's mostly successful where it's cheaper in certain places where the sun is abundant. But I think what's really interesting about this chart from Nature magazine is that over the next 4 or 5 years, solar, I guess with the exception of Norway here, and wind, will be the cheapest source everywhere in the world, even where places where the sun isn't rapidly abundant. And because of this, the market is going to become a huge market, something that I think Dr. Evil would say $1 trillion. So the assumption here came from last year from Science magazine that said that if solar grew from today to 25% a year and then went flat for the next 7 years, it would be $1 trillion. But this estimate is actually wrong in that the last couple of years it's grown by 50 to 60%. So it's actually ahead of schedule for this growth. But, and here's the but, it's not enough. And part of the reason why it's not enough is we're starting what I like this idea of the age of electricity. So obviously electricity has been around for a long time, but we're moving into a world where everything is becoming almost everything is needing to be electrified. So the demand for electricity has been roughly growing a little bit faster than the total energy demand, but it's starting to rocket, where we actually need 6 times the amount of electricity than the overall energy demand. And if you think about that, we can't just be focusing on transitioning our electricity, but we need to be focusing on how do we rapidly expand the amount of electricity we have. Now, I think this is a US view, so it's even more probably understated in that as most parts of the world start to grow their economy and they want to have the same living standards that we have in the US and the West, I believe that even the 6x number, when you add in AI in that, is probably understated. So what are we going to do? What are we going to do about that? Well, let's start with what we're not going to do about it. So one of the things that's been in the news the last couple of weeks is some announcements by Amazon and Google, primarily on small modular reactors, or SMRs, for nuclear. I think one of the things interesting about these announcements is that, first of all, a lot of them are just announcements. They're not actually deployments or funding. They're really just an announcement to intend to maybe do this. The second thing is, if you look at an SMR, they're actually quite small. They're usually about 10 to 20 megawatts. So the total announcements add up to about 1 gigawatt. which is really a drop in the ocean compared to all the electricity that we need. And a lot of these announcements are talking about 2030, 2035. I think most of us know with the combination of both climate change and also the new electricity you need for data centers and AI, it's just a little bit too late. And then I would add to that, even though these are small nuclear reactors, I don't know anybody in the United States who goes, yay, I really want a small nuclear reactor in my backyard. So I think they're going to continue to face some NIMBY and some restrictions. So then we see that there was an announcement, I think last week, about 3 Mile Island and Microsoft reviving this plant. So I think this is a good solution to be able to have more clean energy, but this is really a one-off. There aren't a lot of 3 Mile Islands out there that have been decommissioned and ready to turn back on. So while I think this will help contribute to some of the demand, there's not a lot of opportunities like this around the world to turn back on old nuclear plants. And then lastly, but least, fusion is an exciting technology. I really hope for the sake of the world that it happens and is successful. But most indications are that not only is it a decade away and it's incredibly complicated, but you rarely ever hear people talk about the cost of it. And I think even if fusion power is successful and it works, given the trajectory of solar and batteries, I think it's very unlikely that fusion is going to be a meaningful power source, not because it won't work, but because it won't be able to compete economically because this stuff is complicated and going to be expensive. So when you look at solar, and one of the things that's interesting for me coming into back to this industry for the last year and a half, is that in most other tech industries, there are forecasts and they're usually wrong. They're too optimistic. What's interesting is this slide from The Economist shows that most of the forecasts have been completely wrong by about 3x. And the forecasts have been way under forecasted and probably will continue to be under forecasted for all the reasons I said. There's a flywheel of cheaper costs, electrification of the world, AI, and we're going to need a lot more electricity. And now that solar is the cheapest source and getting even cheaper, complemented by batteries, I think you're going to see this. Continue to be under forecasted. And yes, Christian, I agree. I think fusion might be decades away. I'm trying to be a little bit generous. So what is the solution for this? How do we accelerate solar deployments, and how do we build that more? Well, I think it was interesting in the first part of this morning, the word perovskites wasn't mentioned once, and I would argue, and obviously I have some vested interest. I work in this area, but I would argue that perovskites are really the future of solar, and that they're better, cheaper, more cost-effective, and more efficient. So why is that the case? Well, one is that they're actually 200 times thinner than traditional silicon panels. So they're 1/100th the width of one of your hairs. So fundamentally, they don't have any rare earth minerals or metals, and they don't even need to be mined. They can make in a lab. So I think it would fundamentally be cheaper from that perspective. Secondly, it's just easier to manufacture these. They're more like building thin film or a television versus a complicated semiconductor, although they are semiconductors. And the efficiency today is actually already 30% higher. It's at 27% for perovskite tandems, going to 30% within a year. And then the possibilities to go to 45 or even 50%, whereas traditional silicon is tapping out by the limits of physics at about 26%. There's also not only just the cost of the panel, but there's really, if you think about the total cost of ownership for the utilities, there's a lot of savings that you can get with a denser panel on labor and land, not just the cost of the panel that perovskites deliver. The durability now has been a key concern, but some of the leaders in this industry, including in tandem PV, can now show demonstrated durability for decades. So kind of in line with the warranties that you need for solar panels. And a lot of times perovskites are positioned as a competitor to silicon, but if you think about it, it's actually a complement. And that if you're rolling out tandems, you can leverage all of the existing silicon technology and build perovskites as just a booster, juicing both the efficiency and the power and saving some of this on labor and land. And almost everyone in the technology part of the industry agrees that perovskites are going to be the future of solar. Here's an example from Rethink Research where they're saying by 2040, more than 90% of perovskites will be dominating the share of solar. And I think it's for all the reasons why I just discussed. So and part of the reason why this will happen, it's not only the cost of the panel. I think that we have rightly obsess over the cost of the panel as part of the solution. But if you look at solar deployments today, and I took this from a variety of sources, include ChatGPT, the solar panel can be 10 to 20% of the overall cost when you add in labor, land, balance of systems, the cost of the construction loan. And I think we all know that the cost of the solar panels are going down, while the cost of labor and land and all these other things are going up. So increasingly, as an industry, we're going to have to focus not only just on the cost of the panel, but all the other things around it if we want to lower the overall total cost of solar in the deployments. All right, so kind of summing up, solar is really winning the battle for the transition to clean energy. It's the cheapest source today. It's getting cheaper. And I think there's a discussion of solar being an intermittent source, but batteries are rapidly addressing that to help solar be both a baseline power as well as a peak powering. But I think the main point of this presentation is that transitioning from dirty power to clean power is not enough. We need to grow our electricity by 6x or more. So we need an order of magnitude more solar. And really the only way to do that is to have dramatically more solar all around the world. And really perovskites, I think, are the leading candidate because they're better, cheaper, and really, I would argue, the key to solving this move to net zero over time. So thank you very much, and thanks for letting me talk to you guys today.
Thanks very much, Scott. We have maybe about 1 or 2 minutes here for a couple quick questions. One question we received was, do you see a more immediate market for perovskite silicon tandems versus perovskite standalone? And when would you see standalone perovskites taking over more market share?
Yeah, I think the question is where perovskite's going to play. And I think the initial hypothesis that perovskites are kind of the niche for calculators and cars and other things. But the main market for solar today in the US, for example, 80% of the market for solar is utility scale. So I think it makes sense to focus more on that market if you really want to have more scale. And I would also argue that if you have a choice, if you can build a perovskite panel that is similar and competitive to a silicon panel, maybe even worse to some aspects in efficiency, or you can build a tandem that's 30 to 40% better. For a lot of the reasons I said, saving on labor, land, installation, it doesn't really make sense, I think, in the near term to focus on what single junction perovskites only. Tandems are just a superior deployment. So I expect you'll see much more of that in the near future.
Okay, and I have a question. How soon will we see perovskites installed, and how do you see it becoming the dominant technology in just 5 years?
Well, I don't think it'd be dominant in 5 years. I think that the forecasts are 10% by 2030. I think 2040 is where it'll dominate sometime in the 2030s. I think there's commercialization of some technologies today, but you'll start seeing some scale come out in 2026. And I think that's part of our plan. And then as the technology rapidly commercializes and becomes better and cheaper, I think you'll see the market, just like they've moved pretty rapidly from PERC to TOPCon, moving to perovskites and tandems just because it's going to be so compelling. And as we know, lower costs, both the direct costs and total cost of ownership, really dominates this industry. So I think once you have a panel that's 28, 30%, that's the same or lower cost, everybody's just going to want it. And then it'll be a race for the industry. How do you build it fast enough? I expect we'll be short of capacity for 5-10 years while everybody races to kind of scale up. But the world is pretty good at scaling up at things where economics are behind it.
Okay, well, I think we'll have to end it there, but thank you, Scott. It's certainly has the potential to be a game changer for the solar industry, and we look forward to hearing more about the validation of efficiency and durability and the emergence from the lab into production.
Look forward to being part of that discussion. Thanks a lot.
Thank you. So now we'll move right into our panel discussion on the current state of U.S. solar manufacturing. Let me start by introducing our panelists. Michael Carr is Executive Director of the SEMA Coalition. He's worked for 25 years designing policies and building consensus to advance clean energy technologies. He serves as the Principal Deputy Assistant Secretary for the Office of Energy Efficiency and Renewable Energy and as a Senior Advisor to the Director of Energy Policy and Systems Analysis in the U.S. Department of Energy. He was a member of the leadership team advising the Secretary on clean energy policy and deployment, and prior to serving at DOE, He served as senior counsel to the Senate Committee on Energy and Natural Resources from 2004 to June 2012. Welcome, Mike. And CJ Colavito is the Vice President of Engineering at Standard Solar, a leading U.S. independent power producer based in Maryland that owns and operates more than 350 megawatts of solar across the U.S. CJ joined Standard Solar in 2008 and has risen through the ranks to now lead the design and engineering teams in solar. He oversees engineering, vendor qualification, new technology integration, and management of the engineering and technical departments. He's also both a NABCEP certified solar PV installation professional and an Association of Energy Engineers certified renewable energy professional.
We're
Welcome,
also
CJ.
joined. Thank you. We're also joined by Christian Roselund, Senior Policy Analyst at Clean Energy Associates, where he leads policy research and communication for the Market Intelligence team, covering trade, supply chain, and national policies. Christian has 13 years of experience in clean energy, including as serving as the founding editor of PV Magazine USA and as editorial director for the think tank Rocky Mountain Institute. And finally, we're joined by Craig Walker, sales manager at Soltec USA, a vertically integrated company dedicated to solar tracker projects with solar trackers, with almost 7 years of experience at the company. Known for his customer-focused approach and product knowledge, he consistently exceeds sales targets, and he's contributed to Soltec's growth by identifying new business opportunities. Welcome to our panelists, and thank you.
So, to begin, the U.S. government has set a target of a 50% reduction in greenhouse gas emissions by 2030. A recent report by ACOR and CEA says that many recent models suggest that we'll need 500 gigawatts of cumulative PV installations by 2030 to achieve that goal. The IRA has stimulated tremendous growth in manufacturing, but is it enough to meet our goals? According to SEA, a record-setting 11 gigawatts of new solar module manufacturing capacity came online in the U.S. during the first quarter, or a record-setting 71% increase, which is great. But to really onshore the solar supply chain, we need to step up the pace on cells, wafers, ingots, and polysilicon. We need a balanced supply chain for many reasons, not the least of which John Smirnow emphasized in his keynote, which is national security. So let's dive into these issues. First off, Mike, hundreds of billions of investment dollars are being spent to bring manufacturing back to the U.S. Why are we doing this?
Thanks for the question. Thanks for having me. I think John laid it out well. I mean, this is a matter of both national and economic security in our country, and I think it is important to recognize that there's been a change as we've gone into modern manufacturing, and solar is really at the leading edge of this. In that, when you really unpack it, there's not much or really no comparative advantage from one country to the next. At the end of the day, a solar panel is starts as quartzite or sand, and you apply a lot of electricity and various advanced machining, and you end up with this miraculous product, the solar panel that can generate electricity from sunlight. There's no, really in this scenario, when you have, such a sort of a well-developed and basic approach to developing these panels, manufacturing really ceases to become a question of ability and just becomes a choice. And so I think what we've seen is for 40 years now, the United States has sort of chose to let others take on the manufacturing challenge to an extent now where we have the Chinese manufacturers vastly overproducing what they can possibly consume within their country. And so now we have a scenario where I think for a variety of reasons, including, some of the issues that we saw at throughout the COVID crisis globally, where supply chains became overstretched and eventually really failed. And then also to just sort of having control over what is going to become our dominant energy source in the next coming decades. I think we have policymakers really across the political spectrum and, in and out of Congress, recognizing the centrality of manufacturing, both to our economic security and to gaining the benefits of this economic transition, and to our ultimate national security. Therefore, they've decided to make a different choice, and now we have begun to really make the choice to shift to supporting manufacturing in the United States, and we think it has incredible effects and positive effects throughout the economy for doing that.
Okay, thank you. So since passage of the landmark Inflation Reduction Act a little over 2 years ago, we've covered many, many announcements of companies either coming to the U.S. to set up solar manufacturing or U.S.-based companies expanding capacity. And this is mostly module manufacturing. So Christian, tell us what CEA's view is on how much capacity is actually being built versus announced, and where are the gaps?
Because I have a visual answer to this. So yes, as you've noted, there have been a tremendous amount of announcements. However, as Paula Mintz famously said, it's a long way from PowerPoints to power plants. And I would say that it's an even longer way to a fully operational and ramped factory. So if we look at, and one of the things about the way that we do this, we track inputs of tools to the United States. So if you want to know what's going to come online in the near term, we don't think there's really a better way than looking at which factories have imported tools. Now, that's not the only step, and clearly we're tracking a number of other steps, but for near-term capacity, we feel strongly about that. What we see right now is that on the module side, with the factories that are ramping up, we are going to have enough capacity to meet our needs in the United States. And when you add those factories that are importing equipment, those are very unlikely to not ramp and then start producing. So, we're doing well on the module side. When we look at the cell side, there's a big lag. Right now, we're only looking at one factory that is ramping up. We have others that are importing equipment, and those are promising. We expect those to come online by the middle of next year. Then there's others where the construction is underway. That's also, very hard to back out once you've started to build the factory. So those are promising in the 2026 timeframe. After that, it gets a lot more speculative. And, keep in mind here, we're looking at only 17 gigawatts of crystalline silicon cell compared to the much, much larger capacities of module. For ingot and wafer, similar kind of story here. We have two factories, one of which, take our 5 gigawatt estimate here with a grain of salt, because we've tracked the tools coming in, but we haven't had a definitive announcement in terms of what the capacity of that factory will be. So we're kind of guessing there. But there's nothing else that's really close, frankly. And so for the near term ingot and wafer, we're only looking at 8 gigawatts. And this, as noted by John Smirnow, this is definitely the hardest part. When we start to talk about cell and ingot and wafer, these are more capital intensive. They're a bigger risk for investors to take. There's longer lead times to build these factories, and they're also a greater technical challenge than assembling modules. Assembling modules certainly requires its own set of technical expertise, but I think it's another level when we start to talk about making cell and ingot and wafer. So then, and pardon me, I'm just going to skip over polysilicon here for a moment. But if you look at the combined capacities, and in this slide we did something that's not normally done. We added in the thin film capacities at every level so that we get a better sense of how far off things are. You'll see you're doing great as of next year for module. cell, we still have a gap. There's still a dependence on imports, including for U.S. module makers, and even more at the ingot and wafer level. With new developments in polysilicon, actually, poly is we're looking at having more poly capacity than ingot and wafer domestically in the United States. So this is where we see the challenge really happening. And, I think we're very optimistic about things like the Section 48D clarification that those CHIPS Act, that 25% ITC can be used for ingot and wafer. That's great. Hopefully that will attract more qualified, folks who can actually do this, as opposed to some of the announcements we've heard from players that frankly didn't necessarily have the know-how or the wherewithal to be able to pull this off. But that hasn't manifested yet. And keep in mind that if you're not importing equipment now, you're probably not going to be manufacturing by the end of next year. And if you haven't even started construction on your factory, now we're starting to talk about newly announced projects. We're looking more at the 2027 timeframe. So in the middle here, for the next 2 years, at a bare minimum, we have these significant gaps. Now, also, I would note that this is probably more severe than this chart suggests. The orange line is based upon Woodmac and SIA's forecasts. They've actually already updated this 32 gigawatts in 2023 to 40 gigawatts. And I personally consider this forecast to be a low case. I expect there to be as much as 10 gigawatts of additional deployment and more in later years. So the gap actually gets a bit wider here.
And following up on that, Christian, how do we close the gap? What do investors need to see, and how does the U.S. industry move to address these early legs in the supply chain if we are going to bring more capacity online?
Well, as we've seen, incentives make a huge difference. And I think a fundamental challenge for the Section 45X has been the phase out. These start to phase down in 2030. They potentially phase down further in 2032. Also, we need policy certainty. I think that depending on the outcomes of the election, I think parties may feel more certain investing in the United States or less. And that's a big challenge that we've had consistently in the United States is a lack of policy certainty. Certainly during the Biden administration, there's been a strong commitment to onshoring solar manufacturing. And there has been some interest across the aisle, but I think, we need to see, I think investors need to see that certainty. And so, yeah, the incentives go a long way. And, a great thing about 48D is it doesn't phase down after 2030. That's an upfront, and that addresses the CapEx here, which is a bigger challenge for cell and for ingot and wafer. So I think there's a lot of things. Also, we need players who have the skills and have the abilities to be able to do this. Notably, we've had ingot and wafer tools imported by a major tier 1 Chinese-owned company. Those may not end up in a factory that is owned by that company, but that does give us a sign that there are parties involved in this ingot and wafer plant who know what they're doing and who've done this before, who are currently operating ingot and wafer. And I think that when we're in this environment right now where there's a lot of, frankly, a strong anti-China sentiment that we're hearing, it's notable that a lot of the technical know-how to actually get these factories online is in the hands of Chinese companies. So I think there's a danger here that too many restrictions on Chinese companies and the participation of Chinese companies in this investment could make it conversely harder to onshore certain parts of the supply chain.
Thank you. And I want to direct the same question to Mike. What does an investor need to see in the U.S. market today to support cell and polysilicon and get early stage manufacturing?
I mean, I think Christian really hit it on the head. I mean, if you go and ask to investors, it's all about certainty, certainty, certainty. I think it's important to understand in this context that we're not, we're really talking about scale. That's where a lot of the gains have come in recent years in the solar space. And so what we're trying to do in the United States, and where I think particularly the IRA incentives began to unlock the possibilities in the United States was their incentive for scale, to build fast, build big, and the more your incentives can be. I very much agree that the 48D incentives will be great on the CapEx side. We have tried CapEx before, and without the supporting policies, we found that it was lacking. Now we do have a broader tool chest that the administration has with the 45X, with the domestic content bonus standard, with tariff policies. All these things can work together to incentivize not only growth but scale. But I very much agree with Christian's point that we did have some hiccups, and we haven't seen the uptick happen as fast as one would have liked, as we'd liked, particularly at the upstream side of this. And a lot of that was due to uncertainty, whether it was regulatory uncertainty as the guidance trickled out, as sort of Treasury and Department of Energy began down this frankly new road of industrial policy here in the United States. That has led to some uncertainty. There's of course election uncertainty. One side or the other is certainly more committed to building out this supply chain, committed to the technology itself. So that will begin to clear up, one way or another in the next few weeks. I think Congress does have some jobs ahead of them in clarifying some of these things in the statute, whether it be domestic content, how that applies, how that ramps up over time, and again, maybe extending some of these incentives. But I think what we have established is there are legitimate, credible players who are ready to go big. There are factories under construction that are closer to that sort of global scale that it's really going to be required to deliver a competitive product and to continue the innovation cycles that we look forward to in the United States. And again, I think, if the administration and Congress stay committed to this, I think the future is actually quite bright for building out this supply chain in the United States. It's a matter of commitment.
Okay, thank you. So I want to turn now to domestic content from the buyer's perspective. So CJ, as one who's on the buying end, how important is domestic content to being competitive in today's market? And the second part of the question is it possible to develop 100% domestic content solar power plant right now in the US? And if not, how close can you get with the components that you have?
Great questions. From a buyer's perspective, as an independent power producer, owner-operator projects, Standard Solar is looking to acquire projects and collaborate with developers. We need to be as competitive as possible to win projects from other project buyers. And that means we have to be able to offer the best developer fee, the highest developer fee, the highest value of the project. And maximizing the investment tax credits is essential to doing that. So as far as domestic content goes, if it's possible, if it's practical, if it's accretive to the project's total value, then we need to do it or we won't win. It's that simple. So as soon as somebody's capable of doing it on a specific type of project, then we need to be able to step in and support that equally in order to be competitive. So I think that's essential for us. We see that the first areas we'll be able to do that is in rooftop mounted PV, which can be done very early in 2025 with domestic content racking and domestic content module power electronics, module level power electronics, inverters and equipment. So we expect that to be very soon, but then fixed tail ground mount, it's not going to happen until we have a cell ready in the US that's readily available, widely available, and we can be confident that we'll be able to get that, because the way the safe harbor percentages are sliced up, with 49% of the value comes from the cell. So without it, you're dead in the water, especially with the expected escalation and domestic content percentages required to meet the domestic content bonus. For the second half of the question, I think it depends on what you want to define as domestic content. The old way we defined domestic content was Was it made in the US? Did it come from a factory? The last factory it came out of, was that a US-based factory? And if that's your definition, then yes, we can get a 100% domestic content system with a rack made in the US, with a module assembled in the US, with inverters manufactured in the US, even transformers and switchgear, most other components, unless you get down to the very nitty-gritty, you can get to a largely 100% US system for solar PV. If you want to follow the definitions of what means you get the domestic content bonus according to the Inflation Reduction Act for the ITC benefits, then the answer is no, because they want you to not only assemble it in the US, but you also have to get every single component in the US. And in order to get the manufacturing credit towards that percentage, every single component needs to come from the US. That means for modules, you have to have frame, junction box, glass, encapsulant, cell. There's probably something else I forgot, but every single component needs to be from the US. And today, that's just not practical. You can do it in very, very small quantities for very high cost and a lot of jumping through hoops, perhaps on modules. I know you can get it for inverters today. It's definitely capable for most racking systems. You can get pretty close to 100%, if not 100%, accepting a few small components from some tracker manufacturers. But overall, it's not straightforward, and it really depends on your definition. So I think the industry has evolved dramatically in a pretty short period of time to have a lot of great options for domestically manufactured equipment in the US, but meeting the domestic content requirements is a much bigger challenge. So very happy to see how things have turned around, but we have a long way to go if we want to reach that. And in practicality, it doesn't necessarily make sense to meet that definition for domestic content bonus at 100%, because once you meet the percentage threshold that's required to get the bonus, anything more than that doesn't actually deliver more value to the project beyond intrinsic interest in having a 100% domestic content product.
Right. Okay, thank you. So, Craig, Soltec, a Spanish company, is manufacturing now in the US. What influenced the decision to come to the US? And are your trackers expected to be domestic content eligible? And if so, when? And also, a third part of that question is, how important is it to your customers to have domestic content?
Yeah, so obviously, first and foremost, Anne, Ryan, PV Magazine team, thanks very much for having me on this roundtable and Soltec. Straight to the point, your question, how important is it for us to be able to manufacture locally in the US? I think is an absolute critical point for us to manufacture here in the US for our clients for three very, very basic reasons. Domestic content eligibility, obviously with the IRA incentives, etc. Our customer service being at the forefront of that, transparency, our product innovation, all passing here through the US is another thing that is super important to us. And price and lead times. They're the three biggest factors, I believe, in the US market here for local manufacturing. We can go a little bit further into that, in going into detail of what parts of the tracker we actually have available, how much percentage we're actually able to do up until now. We're aiming to be a fully US-made tracker by Q3 of 2025. We currently have torque tubes, rails, other balance, all being manufactured here in the US. We are finding more and more manufacturers actually coming to us and providing us with those opportunities to cooperate with them here in the US. And we're just finalizing negotiations, basically to align what is our needs along with the guidelines. So we need to make sure that everybody is aligned with how we move forward. So yeah, in short, Spanish company, we are manufacturing here in the US by Q3 2025. We should have 100% US manufactured solar trackers, or racking as you call it.
Okay, and the third part of that question was, how important is it to your customers? Are you seeing customer demand now for domestic content?
Yeah, so I pulled off some of the numbers actually of some of the quotations we've been carrying out from some of our main customers here in the US. At the moment, there's about a 20% split. So we have, out of the 100% of quotations we do, 80% is asking for imported content, 20% is actually asking for domestic content. Now, I believe the drivers in that factor, of course, are CapEx, but what I tend to find and what Soltec tends to find at the moment is lead times are so good in the US that sometimes it compensates depending on the priority and the what I would say the milestones of the project. If the milestones of the project are very tight and you're trying to get them in a lot quicker than normal, then we do look at US manufacturing, over CapEx.
Okay, thank you.
Thanks. So we've talked about modules, cells, and trackers, but there's other parts of the supply chain to address as well. There's glass, frames, inverters, power electronics, transformers, switch gears, things necessary to connect to the grid. So Christian, what does the current landscape look like for manufacturing of these other components, and do we have a roadmap for expanding that here in the U.S.?
Yeah, that's a great point, because when I heard the other responses here, I felt like there's some qualification that needs to be done around capacity, right? You can get a US made inverter today. It's going to be more expensive, and there are not enough of them at the utility scale level at string inverters to meet the entire market demand, right? There's a limited capacity. For trackers, it's a different story. You're seeing a lot more US made trackers. You're seeing actually enough to export. Now, does that mean every part of the tracker is US made? Which again, per the point made by CJ earlier, that's what you need to get the full credit for the domestic product. Not yet, but we're getting there. In fact, when I talked to tracker makers at RE+, I found that pretty much everyone I talked to was going to have a fully 100% domestic product by the middle of next year. So that goes a long way. But when you talk about meeting those domestic content thresholds, it's still really hard without a US cell. Maybe you can get there with fixed tilt, but at this point, I think Berkeley Lab said yesterday that 96% of what we're looking at today is tracker systems, and so in terms of what's deployed at the utility scale. So I'm sorry, and actually it's easier if you put those pieces together with the tracker, the inverter, et cetera, on a tracker system, because it's more of the value. For fixed tilt, you need a US cell. It's pretty much that way. And the other place that we're seeing challenges is exactly that module bill of materials. Not all of the little pieces that are required to make a module are really available to the United States, or available at a reasonable or competitive price. We've seen still we're not seeing frames happen here. It's so much more expensive to make aluminum frames in the United States. Some companies are going with steel frames. We are looking at, I would say, optimistic about backsheets and encapsulants. Those are coming. We've talked to companies who are bringing those online again next year. So the landscape that you're looking at today and the landscape that you're looking at by mid next year are really different. And there's a lot more domestic product available across the entire module bill of materials, across the entire balance of plant, if you talk mid next year, than if you talk today. Still a few places that are sort of holdouts, particularly on the module bill of materials side. And honestly, less progress overall. We're not seeing big inverter manufacturing coming to the United States yet. Certainly for the microinverters, yes, but microinverters make up so much. If you look at the rooftop, if you look at that safe harbor table that was in the N2441, the most recent guidance for the domestic content bonus, if you look at rooftop, US cell is a lot less important. You can get a lot closer with your racking, with your fasteners, and with a domestic module level power electronics. And that's where you're seeing, you know, these microinverter makers and these other, you know, small inverter makers are definitely coming. They're definitely setting up factories in the United States. You should be able to get plenty of those. It's the big inverters where we're just not seeing that capacity move to the United States yet.
Thank you. And for Craig, we've talked a lot about the domestic content bonus and how that's one of the major motivators for manufacturing in the U.S. But you mentioned there's some other advantages like lead times. Perhaps there's cost advantages. Could you talk about some of the other reasons that you would set up in the U.S. beyond the domestic content, and maybe trace out what it does for lead times and things like that?
Definitely, Ryan. I can definitely give you some info on that. Again, as I mentioned, I was running the numbers. I was looking at what sort of lead times we have on projects upcoming, very quickly. It's almost 50% less. We look at US manufactured content can take up to about 9 weeks. From NTP, from contract signature to us providing a manufacturer with a supply, it takes 9 weeks to get the site. Now, when we look at imported content, yes, we are looking at 18 weeks. But not only are we looking at 18 weeks, there's another, a totally different part to this concept that we haven't spoken upon, and that is the insecurity. There is a certain insecurity that comes from any sort of imported content, whether it be political situations, whether it be natural disasters, or whether it be supply chain problems abroad. These three key factors are pushing us more and more towards US manufacturing. Now, the only problem we face at the moment is the price. Okay, lead times are brilliant. 9 weeks is very competitive. As a tracker manufacturer, 9 weeks is very competitive. What is pushing our customers and our clients away is price. There is a delta price difference, which is significant. Now, I'm pretty sure, as Christian was mentioning, and a lot of the panelists, Mike and CJ, the gap is closing. It is definitely closing. It's not closed totally yet. It is closing. When it does close, I am very confident that the US market is, domestic content in the US market is going to be very competitive on long term. And yeah, that's my point on my answer to that question, Ryan.
Excellent. Thank you.
Okay, so let's get back to CJ. From the buying perspective, what are some of the challenges in understanding the 45X credit and accessing it?
I think really understanding how that's going to impact the overall project, how to validate that. We have to work with lenders. It's not what the IRS thinks or Treasury thinks our content is. It's what our lenders think. So, I mean, every project goes through lender diligence and scrutiny. We're working with independent engineers and with our lenders, and we're demanding tremendous amounts of documentation, validation, and essentially proof from our manufacturers that they really do meet these content goals and that they do align. So sometimes that's difficult and it's kind of intrusive working with some of our vendors, but they understand how important it is and that it's essential to the business and to the success of achieving the domestic content bonus, which really, to my knowledge, has not been done yet for a distributed generation project. So a non-utility scale project, non-residential, I don't believe has obtained the domestic content bonus for ITC just yet because of the lack of cells, commercial scale inverter manufacturing capacity and racking validated with a project that's been built and put into service just yet. I expect that to happen very soon, but I think working with lenders is the biggest challenge, and then having good relationships with your manufacturers for transparency, and then just defining and understanding what the documentation is and going through the process. Lenders are the most risk averse, and so you have to work with them, and none of them want to be the first. So somebody has to be first. You have to convince them that it's a good option, it's a good value, and there's no risk. Don't worry about it. We have it. So I think that's really where we're coming from, and we're working hard to broach that and hopefully support taking a lead especially in large-scale rooftop distributed generation projects in 2025. And Christian, I mean, I come to all these webinars, I'm speaking, but I'm learning stuff. The importation of equipment for cells is very encouraging. Maybe I'm convinced that we'll have cells available for the commercial DG and community solar market sooner than end of 2026. I mean, I was just looking at capacity numbers today. It looks like total capacity that sector, the non-residential, non-utility sector of the market is deploying is, shy of 4 gigawatts. So the amount of capacity coming online could more than serve that entire sector. And one point I did want to make is that the value of the domestic content bonus to distributed generation and community solar is 2 to 4 times more than it is valuable to utility scale. So there's a lot more value to us. We can pay the premiums. We want to pay them because it's still accretive to the project values, still delivers, better energy rates to our end customers, better developer fees to our development partners, and better return on investment for our lending partners as well. So I think that we're going to see that happening first, and we're willing to take more risk and be more aggressive at achieving those content goals because they're more valuable.
Yeah, and if I can quickly address that, a lot of the cell capacity that we're seeing coming online is going to be serving the residential and C&I markets and community solar markets. It's a lot more thin when we start to talk about utility scale product.
Interesting.
Though there's some ability to shift.
Okay, so CJ, getting back to the 45X again, even if all products don't meet that 45X threshold, what are some of the advantages of domestic content from your standpoint?
Well, I think Craig really explained that very well. It's the same for us as it is for any utility scale owner, developer, or EPC. We have security of supply chain. We don't have risk with what's going on globally, both politically and with natural disasters. The last thing anybody wants to see is another pandemic affecting one part of the world that has a rippling effect on the entire world and our ability to get things done. We need to be more resilient as a nation and as an industry, and be able to support what's going on locally as well as globally. So I think it's really important. I think from a values standpoint, not value of project, not purely from a business standpoint, but from understanding that we want to support our country holistically. We want to be able to tell a good story to our customers and to our partners and investors that we're doing everything we can to bring in domestic content and engage with domestic manufacturers where it can make sense, because it's win-win. And a lot of our customers are community solar subscribers. They're regular folks who want to save money on energy and use clean energy and see a discount on their electricity bill. And they want to be able to do that and know that they're supporting U.S. jobs with domestically manufactured equipment and clean energy. And I think there's a very holistic story to tell there.
Okay, great. Thank you.
Thanks. And before we shift subjects and move on to from domestic content to more trade-related issues, any other comments from the panel related to domestic content that we want to make?
Yeah, thanks, Ryan. I wanted to just kind of weigh in here that I do want to contextualize this a little bit, in that this domestic content approach as part of the overall manufacturing reshoring effort is very new. This is only a couple of years old in the IRA, and committed to its implementation due to the way the bill was put together to the Department of Treasury, which literally has zero experience in this area. So I think they've done they've had to really get up to speed very quickly and try to figure out, and obviously working with the other agencies. But this to some extent, we haven't done industrial policy in this country in nearly 50 years. So it's not not surprising that the muscles may have atrophied a little bit, and so we're not. I think there was a lot of uncertainty in the initial phase out. I think Treasury has begun to try to kind of put some shape to how domestic content will be implemented. And some of that feedback is really going to have to go back to Congress. I think some of these pieces probably need to be changed at a statutory level, just so that there's a little bit more flexibility and understanding. I think one of the points that both CJ and Christian made that I think is really important is, the way the domestic content bonus has been implemented, in some sense because of perceived restrictions in regulatory environment or in the statute, incentivizing things such as junction box or patents or other sort of smaller pieces of the puzzle is not the way you would sort of, with a clean sheet of paper, design a strategic set of investments. At the end of the day, these are meant to incentivize large scale investments, again, that are difficult, that are risky, and to try to ameliorate some of that risk. And so I think, focusing on pieces of the supply chain that matter, such as the wafer, the cell manufacturing, and maybe, phasing in over time some of the other pieces that may not be as near-term strategically important, would be the preferred approach. Something I think we're going to continue to work with the administration on, continue to work with Congress on, to sort of, again, I think work towards a smarter and more long-term visioned approach to domestic content to supplement the incentives that we have in the IRA.
Yeah,
Thanks.
if I can piggyback on that, I think that Mike makes some excellent points there, that some of the challenges here are written into the law. When you have this structure where you have a percentage of manufactured product, I think that right there was difficult. It was clearly difficult for Treasury to implement. They've taken a long time to do it. Their first attempt was frankly not very workable. And I think that the progress in N2441 was really big in terms of giving some guidance that did not require the end customer to go back to the manufacturer and get direct costs, which we found, that was really problematic. But I think that now there's actually some new uncertainty that's coming with the announcements by Treasury, given that we know now that wafers will be considered, but we don't know how that will work. And I think that one of the challenges that we've had, sort of the stumbles that we've had as we implement industrial policy, which, by the way, has been a sea change in the United States. For the first decade that I was in solar, no one said industrial policy in Washington, right? It was not within the realm of consideration. It was outside the window. Now we have industrial policy. It's clearly effective in terms of onshoring the supply chain, but we're stumbling with the implementation. There's a lot of step forward and steps back. And every time the rules change, that is challenging. That's a challenge for the developers. That's a challenge for the entire industry to adapt to changing rules. So now we have the domestic content bonus set to change again in ways that none of us are really able to predict, but we know that it's coming. And I'd say that that's a further challenge. I say this saying that I clearly understand the need to get ingot and wafer built in the United States. From a strategic perspective, this is the big gap in the supply chain, and this is something we've been warning about for years, that we see a lot more progress in other parts of the solar supply chain versus ingot and wafer. So hopefully we can get this done in a way that's clear, predictable, where the rules are set this time, so that we have less certainty going forward, and so that people can make those plans and invest in those factories and invest in those power projects.
Yeah, and I'll just reinforce exactly what Christian said is, I think the issue we're trying to remedy is that ingot and wafer were sort of invisible in the earlier iterations of domestic content. Now we have a commitment from the administration to make them visible. That's great, and we're looking to see what that percentage is, and we're trying to work with them to find that path, that will allow these factories to open up, and then begin that sort of that beneficial cycle. But I very much agree, and I think all of our manufacturers across the board is once we get to at least a good enough position that these investments can move forward, we don't want to see a lot of changing. From the manufacturing through to the development, the lead times are long, and you need to let these things work through the marketplace and solidify. So that's my I think we're very much in agreement on that. One more step. We expect it to be a matter of weeks, not months, to see that step into the domestic content, and then I think we'd like to see everybody kind of stand pat for a while and let the market do its work.
Yeah, and I hope that those final rules do end up continuing to incentivize U.S. cell, even those that we're not going to have U.S. wafer, given that there's going to be 8 gigawatts of wafer until at least 2027, right? Given that we're not, even under best case scenarios, going to have another ingot and wafer factory besides those two for several years, I really hope that we continue to support the nascent U.S. cell industry, which, by the way, still has 0 fully ramped factories. And only one factory that's even producing test cells. The last time I checked.
Yeah, and I do think the big holdup there has been domestic content and sort of the uncertainty about the different marketplaces and residential versus utility. So some certainty there should help on both fronts. We of course very much agree. These things have to happen in sync, and again, to give a little bit of credit to Treasury, to the administration, that's hard. To make all these things sort of work in sync, and they were given a relatively limited set of statutory language to work with, and so again, I think there's going to have to be a conversation continuing between all the vested parties that will include Congress as they go into a tax bill next year.
Thank you. I want to briefly pivot to a related uncertainty, and that's around trade. We've had some developments with the ongoing anti-dumping and countervailing duty investigations. Christian, could you just give a brief refresher on what happened with CVD and what's possibly upcoming with AD and what to look out for with that?
Sure. Well, with CVD, we got the preliminary determination, and the preliminary determination is important in several aspects. First, when the preliminary determination comes out and is published in the Federal Register, that's when duty applicability begins, unless there is critical circumstances. And there was also a ruling on critical circumstances, meaning that for those suppliers that are subject to critical circumstances, duty applicability goes back 90 days. So we're really talking about product coming in, I believe it's July 6th for critical circumstances or later, and October 4th or later for those countries and those companies that are not subject to critical circumstances. We got the initial CVD rates. They were lower than I think most people expected in most cases, except the all others rate in Thailand, which was set in a way that I think doesn't intuitively make a lot of sense to a lot of people who aren't familiar with Commerce's method of rate setting. The rates were based partially upon something called adverse facts available. There were some respondents to a quality and value questionnaire that did not respond. Some smaller companies that we're not sure if they're even still in operation. Because of that, they got punitive rates, and that punitive rate was used partially to calculate the all other rate in Thailand, as opposed to it being based solely on the mandatory respondent in that case. So we ended up with a relatively high rate for all others in Thailand of 23%, which impacts at least 3 major PV manufacturers. So that may end up changing in the final determination. Ironically, it will change if the mandatory respondent for Thailand, which is Trina, gets a higher rate. Then the rate for the all others will go down, which doesn't make a lot of sense to me, to be frank. The anti-dumping portion of the case has also been very interesting because we have had the Cambodian mandatory respondents withdraw from the case. And when a company withdraws from the case and stops participating, that's when you get the something called adverse facts available, which means that you will get a punitive rate that assumes the worst for your company. Now, I don't think these companies are losing a lot of sleep about this because I think they'd already made other plans. But the thing is, when both mandatory respondents get adverse facts available, that gets applied, then typically, Commerce actually can do whatever it wants then. It's can use any reasonable method. But that's meant in past AD/CVD cases that everybody gets that rate in the country. So we're looking at very high, we expect triple-digit rates for every manufacturer in Cambodia on the anti-dumping side. Those will continue through the final determination, and they won't be actually able to be changed until the first administrative review. So individual manufacturers in Cambodia could come in the first administrative review and petition for a different rate. But until then, basically for the time being, Cambodia is being shut off as a location for manufacturing. And I think if I was buying any product with a cell from Cambodia, I would be very concerned right now in reviewing my contract closely to make sure that you're not liable for sharing any of that duty risk. So a lot of dramatic developments right now. And we're not even to the anti-dumping preliminary determination.
Thank you.
Okay, well, that was a good lead into the next question. So a preliminary decision was announced on CVD, and we expect to hear soon about anti-dumping. So while there's still uncertainty about the final details, SEA expects the impacts to be modest. Mike, what does SEMA expect, and what kind of outcome would be most beneficial to the U.S.?
So thanks for that question. It's, there are a lot of embedded parts to that, to the question. I think just at a high level, frankly, what manufacturers in the U.S. are looking for is again, sort of getting back to the certainty about what does their market look like as they're building their factories. And we didn't see enough certainty particularly with the tariff moratorium put in place and the high degree of imports that we saw through that period in order to justify some investments. And so some investments were delayed or even withdrawn at that point. So I think, again, at a basic level, the fact that the administration is investigating these challenges, and it seems to be aggressively trying to determine, if the playing field is indeed level, and doing their best to try to level it. In our estimation, trade policy is a critical piece, but not the primary driver. And so really what we're looking for is that continued certainty on the incentive side, on the investment side, understanding, the contours of domestic content bonus, those kind of pieces of the puzzle, and, continued investigation and sort of letting the chips fall where they may on the tariff side. I think will provide, enough security that these things, or at least being addressed in short order. I mean, at the end of the day, trade still remains a whack-a-mole problem and a very difficult thing to rely on on its own. And so I think the administration's recognition of that is a positive step. We have certainly, there are certainly members of Congress who have been aggressively looking at new ways to do this. I know Senator Brown in Ohio has a leveling the playing field piece of legislation that we think makes a lot of sense. But given the trade regime that we have today and the circumstances that we have today, investigation and just kind of continued aggressive enforcement is pretty much what we're looking for out of the trade side of the equation.
Okay.
Thank you.
Go ahead, Ryan.
Yeah. One thing that we haven't touched on yet much in this panel is jobs. John Smirnow mentioned there's a really powerful sort of ripple effect with manufacturing, and I think he said, one manufacturing job leads to 7 downstream jobs. According to an E2 report, we had over 42,000 clean energy manufacturing jobs that were added this year alone, and that number has since only increased. So starting with Craig, and I can open this up to the rest of the panel. What is the jobs factor of manufacturing in a certain region? What does that mean for the market, creating more jobs?
Very, very simple answers. It's great news. Yeah. Creating local workforce here in the US is the #1 goal. Not needlessly creating workforce here in the US, but prioritizing the development of the workforce. So making sure, the workforce has the skills needed for the energy sector. If they do not have those skills, teaching them properly and giving them the training and the guidance needed for that workforce to function in the US correctly for the next decade or so, at least. Now, from a manufacturing standpoint, I couldn't tell you from our manufacturer or our suppliers, their ambitions and goals within the US, but Soltec in the US, for example, as a racking manufacturer, we're employing people in the US, and we are fully training them and making them understand how this whole section of the US works. And that's just a basic answer for myself.
Yeah, if I might add a little bit, just because, as within the SEMA coalition, we've been able to go out and actually see some of these factories as they open, and what they sort of mean to the communities. I think beyond John's very correct point that there are a lot more indirect benefits in the manufacturing jobs than there are in some of the other jobs. These are often anchors for communities, and in particular, and so I think there's more of a sense of pride and an emotional response to manufacturing jobs than there are to some other job numbers. And we keep using the word jobs. I think the other thing, and part of why this is the case, is for manufacturing, it's really it's a career opportunity for a ton of these people. And if you go out and you talk to them, this is the first job that they've really had where they can climb the ranks and they can see how they can build a middle class lifestyle around these in these areas. A lot of the build out has been in the Southeast, particularly in counties. I've been able to note, particularly in counties that really suffered the brunt of some of the hollowing out of the manufacturing core in textiles, in low energy manufacturing in past decades, and which is why they have capacity now to take on new manufacturing. They have the electricity supply already there, they have the workforce already there, and And if you start to talk to these folks, that these are folks who were maybe making carpets or flooring or other textiles in the past. That was historically in an unair conditioned factory, and a lot of bending over, working on your knees, and just physically demanding labor. If you look at one of these modern solar manufacturing factories throughout the supply chain, it's a lot of quality control. It's working with machinery and computers and just a new all in air conditioned, sometimes in clean rooms, right? So a new level of kind of manufacturing that brings a lot of pride. And so and that's really the plan, right? The plan is if you have a manufacturing core, then it begins to have these spin-off effects of equipment manufacturing, of services to that manufacturer, and really this all comes with scale. And so I think that's really the biggest piece that we see as the sort of the bright future of manufacturing, because it's a different quality of job, it's a different kind of sort of a grounding in these communities that can, it's going to generate the stories and the continued interest in pushing this forward.
Yeah, if I could piggyback on that a little bit, I think it is really interesting where these factories are being located. Politically, we've had a lot of people come to us and say, well, in a future administration, under a different administration, might the Section 45X tax credit get gutted? Might the ITC and PTC get gutted? And we think they're actually remarkably durable because of the location of these factories in these, in red states. I think it's notable that a few months ago we had 18 Republican members of Congress send a letter to House leadership saying, don't mess with the ITC and the PTC. We didn't vote. And by the way, they said, we didn't vote for them and we don't think they should have passed. But now that they're here, they're creating investments in our communities. And therefore, if you cut them, you're going to mess up our district. So don't do it. And that's just at the project level, right? That's just at the level of solar and wind plants being built, which, as we've noted, those are construction jobs, very few, limited number of O&M jobs. Those aren't the construction jobs are going to come and go, right? This isn't building a factory. So I think that makes this a lot more durable. And, I think it's a very important consideration. But I also want to go back to the point where, I agree with Mike that the industrial policy here is certainly the much more important part of ensuring that we have these factories, that these factories get built. We tried to do simply trade policy without industrial policy previously, and it was whack-a-mole. Factories went to other countries. Notably, after 2018, there was the Section 201. In 2018, former President Trump imposed Section 201 tariffs, and we did see a modest build out of U.S. module factories, but really it wasn't very impressive, and it didn't get us to the point where we were self-sufficient or, and some of those factories didn't even last very long or weren't very successful. So, but Section 201 was very different than AD/CVD. One of the things about Section 201 is that it was at a set level that would, decline or raise predictably, and not like the way that and it was global. Right? So you weren't going to go to another country unless you went to limited number of countries and get away from having to pay Section 201. AD/CVD is very different. AD/CVD is unknowable in the future. It changes every year, and it really introduces a great degree of uncertainty. And then at the end of that, what you get factories relocating to non-AD/CVD nations, which frankly, I believe is already happening. For some of these countries that are under investigation, tools are already moving to go to other countries. And so we'll be doing this all over again. So I see AD/CVD as having a big impact, larger impact on solar deployment and uncertainty in the industry overall, with a lesser impact in terms of bringing actual factories and jobs back to the United States.
Great. Well, I think that's a great time for us to close out the discussion. We've just run out of time. Want to thank all of our panelists today. Really exciting discussion. As you mentioned, we didn't even talk about industrial policy 10 years ago, and now we're really getting into the weeds with it. So that's something that's to be really excited about. So thanks again to our panelists today.
Thank you.
Thank you very much. Have a good day.
Take care.
And now
All right.
we'd like to draw the prize for you today's attendees. One of you will win a 1-year subscription for our digital PV magazine. We're spinning the wheel now, and we'll see who the lucky one is. Karen Byers, you won a 1-year digital subscription to PV Magazine. So we'll reach out to you with further details on how you can get your prize. Congratulations. So that concludes PV Magazine USA Week, but please do stick around for the networking session with fellow viewers. Today we covered new developments in solar module technology, details on transferability, and took a deep dive into the growing yet challenging supply chain in the U.S., as well as what's being done with solar modules at the end of life. What we've talked about on these 3 days is exciting and optimistic, although many challenges remain, not to mention the fact that we have an election in 2 weeks, which brings another level of uncertainty. One thing I think we can all agree on, though, that this is an exciting industry to be in. The solar industry is stimulating the U.S. economy, training people for important jobs, and contributing a cleaner world for our next generations. Thank you to all our speakers and panelists for taking the time today to share your expertise with our audience. And thank you to our partners, Longy, Trina Solar, Aurora Solar, Soltec, and Stobly. And of course, thank you to the PV Magazine team, both here in the US and in Berlin. Now, please join us for our open networking session to discuss the topics we covered today. We'll turn it over to our colleagues, Frederica Breyer and Bernadette Geyer, partner and sponsored content manager. This is our opportunity to connect directly with industry peers, ask questions, and engage in meaningful discussions, all in real time with both camera and sound enabled. Thank you for joining our first PV Magazine USA week. We hope to see you again next year. Welcome, Frederica and Bernadette.